So, what is an angle? The term angle is used in real life, and it is also used as a mathematical term. I want to focus our attention on the use of the word angle in mathematics. But believe it or not, the term angle is actually refers to three distinct mathematical objects that are not equivalent to one another. So, the word angle can be used to denote even more things in life, but in mathematics alone, it already denotes three distinct objects. The first object is the geometric angle, formed by connecting two rays. A ray is half of a line, so a line which is but only half of it, so the other half has been discarded. So the geometric angle, so this configuration, the two rays connected together at their origin, that is a geometric angle. Next, the angle measure of such a geometric angle. I'm going to elaborate on what that angle measure is in the following slides, but for the time being, think of the arc connecting the two rays. So this blue arc here, connecting the two rays of the geometric angle. And finally, the third different meaning of the term angle is the angle measure of a rotation. That term is also used in real life. So in real life, when you say to rotate it at 180 degrees, or to rotate, make a full turn, that would be rotation of 360 degrees. So that meaning of the word angle is the same as the angle measure of a rotation. Now, as you can see, angle measure of rotation, that's again denoted with an arc-like picture, but you will notice that the angle measure of this particular rotation appears to be a picture, an arc which spans more than 360 degrees, so more than a full turn. So that's going to turn out to be the main difference between the angle measure of a geometric angle and the angle measure of a rotation. We'll elaborate on this later. All three of these terms are referred to as angles. And we as mathematicians have to use context to decide whether angle means angle formed by two rays, whether it means angle measure, or whether it means angle measure of a rotation. Except for a few introductory slides, so essentially except for the slides in this lecture, we'll take full advantage of this convention that, when we say the word angle and which of those three notions we mean, it's up to you to figure it out. So yes, that sounds a bit unpleasant, but that's how it is. Okay, now let's focus on the geometric angle. A geometric angle, or angle for short, is the figure formed by two rays called arms sharing a common endpoint called the vertex of the angle. So these two rays would be called the arms. So those are the arms of my angle. This point here, the start of the two rays, would be called the vertex of the angle. Yes, one more important thing, the rays of a geometric angle are assumed ordered. So they are not equal, they both look like rays, but one of them is declared to be the first and the other one is declared to be the second. So the ray that comes first would be called the initial arm, or sometimes people say the initial side of the angle, or the first side of the angle. And the side that comes second would be called the terminal arm, or the second arm of the angle. So this would be the terminal arm here. Which one is the initial and which one is the terminal arm is that needs to be specified. It is not clear if we do not indicate it with text or in some other way. Angle measures are depicted as arcs pointing from the initial arm of a geometric angle towards the terminal arm. So if you want to depict this angle measure, you start at the initial arm and you go towards the terminal arm. So that would be the angle measure of this geometric angle. And the angle measure is not allowed to be in this direction. So this is not the angle measure of this particular geometric angle, because in this particular geometric angle we're told that this is the initial arm and that's the terminal arm. By convention, the rays are allowed to coincide. The resulting measure of the resulting geometric angle would be called the zero angle. So that's the case when we have the terminal arm coinciding with the initial arm. A ray can be identified by its starting point and any other point on the ray. Therefore, an angle can be identified by its vertex, so that was the vertex of the angle, and one point on each of its arms. So if I pick one point on this arm, I've identified the first arm of my angle, and if I pick another point on the terminal arm of the angle, I've identified the terminal arm of the angle. So if A is the point on the first arm, different from the vertex, and B is a point on the second arm, different from the vertex, then we denote the resulting angle like this. Angle AOB. 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 Angle AOB. So when handwriting angles, it is sometimes people put an arc. So if you want to handwrite angle AOB, you may put this angle sign and then put an arc through it. So that's the convention. You write an angle sign with a small arc. When typing typed texts, we do not put the arc usually, but rather we omit it. Okay. So the choice of the point A and the choice of the point B, that choice is not unique. For example, suppose that I chose point A prime on the first arm, then angle AOB would just be the identical angle as the angle A prime OB. So that would be A prime OB. Right, so these would be just identical angles. It's the same object. Now, when we write angles, the order of the letters is very important. So AO is the initial arm of the ray, and OB, the second pair of letters, is the terminal arm. And the vertex is always in the middle. So the vertex is always in the middle. So when I deal with this angle notation. Now, in the angle BOA, that angle is completely different from the angle AOB. So if I take the angle BOA, then the initial arm would be BO. So this would be the initial arm here. So if I took the angle BOA, then the initial arm and the terminal arm would be swapped. So OB would be the initial arm and the terminal arm would be OA if I were to write the letters in the opposite order. Then the angle measure would be depicted as an arc which points in the opposite direction. Once again, the angle measure of a geometric angle always points from the initial arm to the terminal arm. The two angles are, of course, the two geometric angles AOB and BOA are different. Now, I used the word geometric angle or radian measure of a geometric angle. I already used it, and I already depicted it with this arc from the initial to the terminal arm. But I didn't tell you. I somehow used it informally. I didn't give you a formal definition of that measure of a geometric angle. Let me give you now a formal definition of an angle measure of a geometric angle. So here's how the definition goes. The magnitude of the angle measure of a geometric angle is the length of the short arc cut off by the angle from a radius 1 circle centered at the vertex. In other words, if I want, so in other words, the geometric measure, the measure of a geometric angle, that's a length, right? So that is a length which is given in the following way. You take a circle with radius 1 unit. So we take a circle of radius 1. That's my red circle. You put that circle, you center it on the vertex of the angle. So you make that circle there. And of course, the angle chops that circle into two pieces, a short arc and a long arc. The magnitude of the geometric measure of an angle is the length of the short arc, not the big one, but the length of the short arc. Whenever traversing the arc from the initial arm to the terminal results in a clockwise motion, we take the measure with negative sign, else we take it with positive. So I told you what's the magnitude of the measure of a geometric angle, but now I have to tell you whether it's a positive quantity or whether it's a negative quantity. So the convention is that if this is the initial arm and this is the terminal arm, well then, in order to go from the initial to the terminal arm along the short arc, we'd have to go clockwise, right? That's a clockwise motion. And when we're going clockwise, clockwise means negative sign. So that angle here, from here to here, would be negative. And in the opposite, if we were to move in the opposite direction, that would be positive angle. The unit of this angle is called radians, and it is denoted by rad. A circle of radius 1 has circumference 2 pi. Here's a convention. A half-turn angle is measured with pi rather than negative pi. Right? So if I'm to take the geometric angle, which is formed by gluing together two rays which lie on the same line but point in the opposite direction, then the unit circle, my unit circle, would not have the two arcs which are chopped by the unit circle would be both of length pi, and it wouldn't be clear which one is the initial and which one is the terminal arm, because it wouldn't be clear which one is the short arc. So we could either go in this direction or in that direction. So by convention, a half-turn angle is measured with pi rather than with negative pi radians. So a geometric angle is measured with a number between negative pi and pi, right? Because the short arc is never more than pi in length. So all possible geometric angles are measured with a number between negative pi and pi. Angle measures are frequently denoted by Greek letters such as alpha, beta, gamma, theta. So we often use such Greek letters to denote angle measures. Now, one more important detail. You are going to hear that that angles do not have units, right? So you're going to hear, many people are going to tell you that angles do not have units. That is correct for when by angle we mean angle of rotation. So the third meaning of the word angle, that statement makes perfect sense. When we speak of a measure of a geometric angle, whether a geometric angle should be assigned units, measuring units, or not, so the measure of a geometric angle, that is actually a matter of convention, that is not fixed. So here I'm not violating any standard convention that angles are unitless. because I'm not talking about an angle of rotation, but rather about the radian measure of a geometric angle. Okay, so I'm free here to declare that measures of geometric angles do have a measurement unit, which I've called here radians. All right. And now in the previous slide, I used freely the meaning I used freely the knowledge of what's arc length. So in the previous slide, let me go back for a second. In this slide, I took that arc and I found the length of this arc, right? So I found the length of that arc, and I used that to denote the measure of a geometric angle. But what actually is the definition of an arc length, right? Because I am using that, so I'm assuming that all of you know what's the length of an arc of a circle, but have we actually covered the definition of what's the length of an arc of a circle? Well, we actually haven't. That's actually a fairly involved topic. There is a definition of arc length of an arbitrary smooth curve. So I give you an arbitrary smooth curve, something like this, and I can automatically define arc length for that curve. Okay, so there is such a definition. It is a strict mathematical definition. However, that definition may be a little bit too advanced for the exposition here. Okay, let me just give you a sneak preview of what that definition talks about. The definition states that the arc length of a smooth curve is the limit of the lengths of ever finer straight line approximations. Okay, so if I wanted to tell you what's the length of this curve here, I'd have to take ever finer straight line approximation. So this is a 2-segment approximation of that curve. This is a 1, 2, 3, 4-segment approximation of that curve. So what I have to do is I have to take ever finer approximations of that curve. So I would have to select various points on that curve and connect them with straight lines. And what I would get is approximations of that curve. And by making them ever finer, I would get ever better approximations of the length of the curve. And taking the limit of those lengths as the number of sampling points tends to infinity, I would be getting the actual length of the curve. The details of how this is done. So what does it actually mean when I'm talking about infinitely many, the limit as the number of segments tends to infinity? What is the formal mathematical definition of the word limit? That is too advanced for the present discussion. In fact, a proper definition would require usually integrals, the notion of an integral. That is already calculus level material. So we're not going to do that in the present lecture. Okay, of course, feel free to look it up or continue in this series of lectures, and we'll get to the notion of an arc length. Until we have studied integrals, we ask the reader to think of arc length as of a curve as the quantity obtained by aligning a rope along the curve and measuring the length of that